Okay, so this is the last video we're doing for this block of work on area, perimeter, volume, etc., where we're going to take what you already know about basic shapes and put it together to work on what we call composite shapes, shapes which are made up of 2 or 3 or more smaller shapes. Before I move on, just the kind of key concept here is to be able to consider how a more complex shape is made up. It might be made up of 2 shapes that are added together, such as this example on the left, where if I split the shape along here, I have what I would call shape number 1, or a rectangle, and I have shape number 2, which triangle on top of it. Then I can find the area by taking area number 1 and adding on area number 2. Or what you might have is the shape on the left, where area number 1 would be the green square in the background, and if you were asked to find the shaded or green area, then you would have to take the area of that bigger square, take the area of this circle in the middle, which I call circle number 2, and that's obviously one shape cut out of another or taken away from another. So in order to work out the total area there, we would be doing area number 1 take away area number 2. Okay, make it really plain when you're working how you are doing this, whether that be noting which ones you're taking away from which, whether that be splitting it up into smaller diagrams, as long as you're making it really clear what you do. So what I'm going to do is look at 2 very quick examples of this, because you've done a few of these in class and you should have no problems, which are going to focus on the skill of finding any missing dimensions and of combining together the shapes. So our first example here is what looks to me to maybe be the side of a house. It's defined as a rectangle, and on top of that rectangle is an isosceles triangle. It's important, as you'll find in a minute, that it's an isosceles for working out the perimeter of the shape. So what I'm going to do is I'm going to split it across the middle to give me a rectangle on the bottom, which I'll call shape number 1, and a triangle on the top, which I will call shape number 2. Do I have all the information I need to work out the area of shape number 1? Well, that length there is 8, and that length there is 6, so yeah, I do. So area number 1 is 8 times 6, and 8 sixes are 48 centimetres squared. Area number 2, the triangle is a little bit more difficult. I don't immediately have all the information I need to work out the triangle. What I am lacking, if I look straight at the diagram, is this. It's my perpendicular height for the triangle. So how do I get that? Well, from top to bottom of the entire shape is 12 centimetres. From the bottom to here is 8. So if I use that 12 and take away 8, I am left with 4 centimetres of height for this top part. So that now means, when I combine that with the base of the triangle being the same as the width of the rectangle, I have all the information I need to work out area number 2. So area number 2 is going to be a half times the base times the height. So a half times 6 times 4. Half of 6 is 3, 3 fours make 12 centimetres squared. Now what I have to do is work out my total area, and again I am going to make it really clear that I have added together those 2 areas. Total area is 48 plus 12, which gives me 60 centimetres squared. Okay, I then said I was going to work out the perimeter of the shape, didn't I? So perimeter, remember, is all of the outside edges. I'm just going to quick show you what we already have then. So I know the 8 here, I know the 6 here, and I know the 5 here, just from looking at the diagram. Well, this is a rectangle, which means opposite sides are going to be equal, so there's another 8 there. And this is an isosceles triangle, So we're going to have another 5 there. So if I pick up a different colour pen, in order to work out the perimeter of the shape, my perimeter is simply the total of all of the outside edges. So 5, add 5 makes 10, add 8 to make 18, add another 8 to make 26, and add 6 to make a perimeter of 32 centimetres. Okay, let's look at one more shape, and in that shape there's a little bit of a twist in the tail involved as well. So here I've got this red rectangle with a semicircular dome on the top. It might be the shape of like a drawing of a doorway, it might be the shape of a drawing of a post box, or it might just be a random shape that's been created for you. I've left these dimensions like this because if you remember back to when we talked about volume and liquid capacity, we said we always maybe want to work in centimetres, and I tend to think it might be easier to do that here. I've got 30 millimetres here, I've got 20 millimetres here. If the question didn't say to me give the area in millimetres squared, then I could just change those into centimetres, which might be a little bit easier to work with. But let's assume for just now that you have been told to work in millimetres. Okay, you've been told not to change around anything. So the shape's already been split for us. We split in the middle across there to give us the rectangle. I say split in the middle, it's not the middle, split vertically, horizontally. It's been a long day. Split horizontally to give you two shapes, a rectangle and a semicircle. So let's call the rectangle shape number 1, semicircle shape number 2. I'm going to work out the area of both of those shapes. Now, for the semicircular part of the shape, well, what I've got here is the diameter of this all the way across. It's going to be the same as the width of the rectangle. So D for diameter is going to be 20, and R for radius is going to be 10. And that's going to be important in a minute because the area formula needs us to use the radius. So let's just work through this quite quickly. So A for area number 1 is the length times the breadth of that rectangle, or 20 times by 30. Split that up as 2 times 10 times 3 times 10, so 2 3s are 6, times 10 is 60, times 10, 600. Oops, I made a mistake there. I nearly wrote centimetres squared just after talking about units with you. 600 square millimetres. Area number 2, so that relies on us using the formula pi r squared. So 3.14 multiplied by the radius of 10 multiplied by the radius of 10 again. So what I'm doing is I am moving all of my digits over to the left once to multiply by 10, and then moving over to the left once again to multiply by the second 10. So that's going to give us 314 millimetres squared. So my total area is going to be the sum of these two. It's going to be 600 plus 314, which will give us 914 millimetres squared. Okay, perimeter is a little bit trickier. I'm just going to break this down for you. Let me use a blue highlight, because I don't think my yellow one's going to show up very well. If I highlight the sides of the shape that we already know, so we know that 20, we know that's an exterior edge, we know that 30 is an exterior edge, and we know that this opposite side of the rectangle, so also 30, is an exterior edge. What we have left is this lovely semicircular curve here. That is, when you move on to National 5 Maths, what you would call an arc. We don't have any particular way of working those out yet, except just to say that we know that that is half of a circle, so half of the circumference. So before we work out the perimeter, what I need to do is I need to work out that curve. I'm just going to say curve here. So that is pi d, pi times the diameter, divided by 2. Okay, I don't need to work out what pi d is and then divide answer by 2, I can do it all at once. So 3.14 multiplied by 20, all divided by 2. Now, let's think back to when we were doing our fraction work. I could do some cancelling of fractions here just to help me. I could cancel that 2 down with a 1 and cancel that 20 to make a 10, just so that becomes 3.14 times 10. You don't have to do that, you could do 3.14 times 20 and then half your answer. Just a wee shortcut. If I have two things multiplied by the top of the fraction, I'm dividing by 2. If I have one of those things, then that does my work for me. So that's 3.14 millimeters. No, it's not. It's 31.4 millimeters. That's what I get for trying to write and talk at the same time. 31.4 millimeters. So the perimeter is now going to be my 30 here, my 30 here, my 20 here, and my 31.4 up here. So P for perimeter is 30 plus 30 to make 60 plus 20 to make 80 plus 31.4 to make 111.4 millimeters. Okay, now you might come across other shapes, but ultimately if you remember these simple steps, breaking the shapes down, adding together the constituent parts, or taking away any parts that have been taken away on the shape. It'll be obvious from a question where something has been cut out of a shape or taken away, or it talks about the remaining area. Those are the kind of clues you want to look for that shows you're doing a takeaway composite shape. Okay, but that's all done, so I'm going to upload this video, and that should be everything you need to revise this block of work.